Good morning to one and all. My name is Kunta Vignesh, and I'm currently pursuing my BTech from St. Peter's Engineering College. So today's topic is about satellite communication, key concept and applications in basic communication systems. So firstly, what is satellite? A satellite is a stationary device or a moving device which revolves around the Earth and which receives signals from workstations. Workstations are nothing but ground stations. So let's deeply talk into. Now, satellite communication plays a vital role in modern telecommunications, offering a wide coverage and reliable connectivity. It enables communication in remote areas where terrestrial networks are limited or unavailable. This presentation explores the core principles. So, what is satellite communication? First, we need to know about that. Satellite communication is a method of transmitting signals through a space using satellites. It is a communication used for signal transmission through space using satellites, which are revolving around the Earth. This satellite acts as repeaters, amplifying and retransmitting signals to cover large distances. First definition, it's completed satellite communication involves between the ground station and satellites orbiting the Earth. It relies on uplinks and downlinks. So you are really seeing in the picture that there is a diagram in my PPT. Just see the image. The antennas which are bottom are ground stations. When they are the there is a flame from left to right. The first flame is like we are sending a signal to the satellite, and the second flame which is coming down, and the other ground stations are receiving it. This is called satellite communication. The satellite is used for communication between larger distances which are far away from ground stations, which are far from ground stations. And how it works. First, signal transmission. A signal is transmitted from a ground station to the satellite. Like you can see in the image that the flame, the orange color flame, think as it as a information or something or a signal. We are firstly transferring the signal from ground station 1 to satellite, and then we are receiving here. See, once wait a second. I'll just try to. All right, green button. This is one. The, the arrow. This is the first. Okay, what is that? I can't. Can I lock? Can't I lock it? I think I can't lock it. This is for. Wait a second. I think this is not working yet. Draw. Bulk. Let's see. This is the first transmission of signal to the satellite. This is the satellite. Wait a second. Satellite. And this is the receiving. This is the receiving area. Oh, why this is open? Hmm. Right, highlighter. Okay. This is the receiving area. You can see. This is the transmitting area, and this is a satellite. The middle circular one is satellite, and this is the receiving ground station. So, firstly, a signal is transmitted from ground station to the satellite, and then the satellite sends the first it amplifies the signal and then sends to the ground station. That is called signal amplification. The satellite amplifies the signal to compensate for attenuation during transmission. Attenuation means any signal loss. We should not have any signal loss. That's why we are using signal amplification. Signal amplification, if we lost the signal without amplification, if we lost the signal, the information is gone. But when we amplify the signal strength, if during the loss of a signal, we can extract the information. And the next, okay, stop it. And then next, types of satellites. Geostationary satellites. I think I need to erase them. Erase. BCS means it's a basic communication system, but here they are giving as we can conclude it as broadcasting and communication systems. Use geostationary satellites So, next. For their requirement, we can use how many we want. There are geostationary, primary, and secondary satellites. And the key components of satellites are, first we need to have a satellite, and then we need to have ground stations and responders. Matlab, it means transponders. Satellites operate in three primary orbits: geostationary, medium Earth orbit, MEO, and LEO, low Earth orbit. These are the, for geostationary, it is a fixed. MEO LEO satellites provide lower latency and improved signal strength, enhancing communication quality and flexibility across various geographic regions. So now comes the applications. Applications of satellites in BCS. It's first one, telecommunication. Satellite communication provides global connectivity, especially in remote or undeserved areas. And then broadcasting. Satellites transmit television channels and radio signals worldwide. Navigation. Satellites like GPS provide locations, information, and timing signals. Now, weather forecasting. We can also predict the weather by using satellite communication. Satellites monitor weather patterns, helping predict weather conditions, as you know. And then next, what are the advantages? First, we need to talk about the advantages of this. These are normal. Emergency disaster, to survive. Satellite communication is essential for extending the reach of broadcasting, internet, and emergency services in BCS. Utilizing various satellite types and orbits, it provides flexible, reliable connectivity worldwide. The technology bridges gaps in terrestrial networks, supporting critical communication needs across diverse geographic. So, what are the advantages? First, we need to talk. We can cover global. We can cover whole globe. That means global coverage. It can be seen as global coverage also. Satellites can cover vast areas. Means that means large areas, including remote and inaccessible regions. Remote areas means where there are no towers. We can we can locate on the map and something. Satellites can cover those areas also. Next, satellite communication is also very useful through satellites. Now, day before in this 2025, we also have a tragic attack like Palgam attack, where the terrorists were tracked using the satellites. Using the satellite only, we have got their images and we finished them. Next, reliability. Satellite communication can be more reliable than terrestrial communication in certain situations. That means we there is no loss because we are using signal amplification, so there is no loss of losing the information. What are the challenges faced by satellites? Latency. Signal transmitted via satellite experience delays due to the distance they travel. If the satellites are far from Earth, however they are far from Earth, so it may be delay, and depending on the network we can uh, get the signals. Next, interference. Satellite signals can be affected by interference from other satellites or terrestrial sources. This is not other satellites. That means you can also say that as obstacles. Any objects, any objects blocking the signals like this. If this is an object, this is a signal transmitting. If this block, we cannot get the signal. These are the challenges. This is called interference. And then future developments. Higher throughputs, higher output of satellites. That means we need to get more reliable. If you know, new satellite technologies aim to increase data transmission rate. That means the data transmission rates should be increased, and the capacity of the transmission also should be increased. Next, LEO satellites are being launched to reduce latency and improve global connectivity. Okay. So here is a brief description from the starting. What is satellite communication? Satellite communication is used for communication between both ground stations using the satellite and signals. Firstly, how it works. From the ground station one, we will get a signal. We will transmit a signal to the satellite, and then amplification is done in the satellite. Then the signal is retransmitted to the ground station two. This is the process. What are the components need? All workstations. That means ground stations and satellites and signal transmission, transponders. That means the response. And more applications are telecommunication, broadcasting, navigation, and weather forecasting. Already all the stuff is done. Once I need to talk to you about huh, this. Satellite orbits and coverages. Here there are three types of satellites. There are geostationary, MEO, middle Earth orbit, medium Earth orbit or middle Earth orbit, LEO, low Earth orbit. That means low Earth orbit covers only small data. That means only few coverage. We cannot say few. It also covers vast, but comparing the other two, geostationary and medium Earth, it is comparatively less. Geostationary is a vast. Medium Earth orbit is some low from it covers less distance than geostationary and more distance than LEO. Then low Earth orbit covers less distance from the other. This is it. And applications here, broadcasting and media distribution. This media distribution means it is DTH. Broadcasting is also DTH only. These are the channels. That means Airtel DTH, Sun Direct. These all the antenna receives the signal from the satellite. We also get vast coverage of the area. Next, internet and data services in remote areas. Internet, as you all know, in remote areas also we are getting internet nowadays. Data services means that is only internet services. Next, emergency and disaster communication system. Satellites offer a vital communication capabilities during emergencies and natural disasters when ground infrastructures are compromised. We can detect any disaster via satellite, through satellite. That means tsunami, cyclone, and weather conditions. Depending on the weather condition, we can predict. And then next conclusion. Thank you. Have a nice day.